Welcome back to McClutchy Maths. My name is Natalie McClutchy, and today we are continuing our video series with the 11th video on how to write a problem-solving modelling task. And this is for 2025 syllabus in Queensland, Australia. And we're on to the communicate part of our assignment, how to use appropriate mathematical language correctly. Now, before we get started, I just want to tell you how you can engage further with us here at McClutchy Maths. Why not like and subscribe and hit that notifications bell? Do it now. Just go and click that and you'll always know when the next video is available to watch. Why not tell someone about this video? If you're a teacher, you could share it on your class OneNote. You could also consider playing parts of this in class leading up to handing out the assignment. You could also follow us on social media. We're on Facebook and Instagram, and there's a new way on YouTube where you can actually say thank you back for the time this has saved you and the help and support that this has given you. It's a $2 short donation that you can make very quickly using your PayPal account. And I'd like to shout out to superfan Jason T, who has made us a few donations. We really appreciate it. It helps to keep our channel going. Well, let's get straight into the video. We're going to look at our instrument-specific marking guide, the ISMG, and we're in the communicate section. It's worth 4 marks out of a possible 20 on your assignment. Now, this is quite different to the way the ISMG used to look. Our focus here in this video is using appropriate mathematical language. So if we use it correctly, we hit in the 3 to 4 range. If we use it most of the time, appropriately, then it's going to hit in the 1 to 2 range. So the focus is on mathematical language here. Now I'm going to do a very quick comparison of what the ISMG used to look like and what it looks like now. So before there were 2 dot points. Now this made it hard for teachers when we were marking to work out if it was a 3 or if it was a 2, because you could have had 1 here and 1 here. Who was to say whether it should be a 3 or a 2? That was sort of really down to teacher judgment. Whereas now that we've got these 3 dot points up here, it makes it really clear, because if I've got 2 here, it's a 3. If I've got 1 here, it's a 2. If I've got 3 here, it's a 4. So it's really easy now for teachers to mark. Okay, before we were focused on appropriate technical vocabulary, procedural vocabulary, and conventions. Whereas now it's all about the mathematical language. Okay, we're not going to talk today about the logical organisation of the response. We actually did that in our first video when I was talking about how to set the assignment up. So we kind of split communication that way, because a lot of kids just want to know, how do I get this thing started? Our next video that we're going to do is going to be on this justification of decisions. That wasn't in the 2019 part for communicate. It was actually part of evaluate, and it's now been moved into communicate. You'll notice now that this is also much more student-friendly. It's a lot less wordy, and it doesn't leave up to interpretation as to what technical and procedural vocabulary and conventions mean. I'm sure most students would not have a clue what that's talking about. So it is much more student-friendly. And there's that big focus on the maths language, not the normal language that we use to describe things. So we're not really focusing so much now on how good you are at writing, just how good you are at writing about maths. And this mathematical language is an all-encompassing term. It actually does cover the technical, procedural vocabulary and the conventions of mathematics. It's now just all under this one banner. So like I said earlier, if you want to cover this one here, logical organisation, that's the blue video, the very first one in the series you need to go and look for. Okay, so mathematical language, what is it? Well, in the new syllabus for 2025, early on in the syllabus under Objective 3, it's defined as terminology, symbols, conventions, representations, and everyday language. It's about how we organise and represent our information in graphs, using symbols, and also describing and representing mathematical models. So it's covering the whole assignment, the mathematical knowledge that you've shown when you've done your graphs, when you've used algebraic techniques, and when you've talked about both of those. All of that is encompassed in this mathematical language. So you'll notice that spelling, grammar, and punctuation are not requirements anymore. Before, these things affected your coherence under the old ISMG. So people who made spelling mistakes that created a word that spell check didn't pick up. So for example, if I had used the word head instead of had, it makes the flow of the sentence sound more confusing and less coherent, but it doesn't get picked up by spell check. So things like that are no longer requirements as part of marking your assignment. So you can be terrible at spelling now. You can have your assignment full of grammar issues and punctuation issues. it's no longer going to be held against you. However, I would still recommend using that spell check, using your grammar check, because if your assignment is horrible to read because of all of those issues, it makes it much harder for your teacher to stay focused on finding the evidence for you. We're all human. So coherence is no longer part of the marking scheme. So you're not being judged on your ability to write paragraphs. This is not an English assignment, but you are being judged on your ability to use that mathematical language. So this actually might even be harder for some students to hit this one effectively if you're not confident with the maths knowledge. That's why it's important to understand what you're writing about before you write about it. So like I said, this makes it much easier for your teacher now to find the evidence to support your grade if you're using the spell check. Read your response out loud to make sure it makes sense, and don't try too hard to sound super intelligent and make your report incoherent. I do see some students put things into ChatGPT and it comes out sounding very, very smart, but when the teacher's reading it, they've got no idea what you're talking about because the computer's basically written it for you and it doesn't read nicely for a teacher. So if you want your teacher to find that evidence for you easily, with the time constraints that they have, do your very best to make it easy for them to read. So what is your teacher going to be looking for? Correct communication of those mathematical terms that relate to your subject area and the principles that override all mathematical topics. So things like, I'm going to give some examples now. If you've got bivariate data or time series assignment, you know the difference between the correlation R and the coefficient of determination R squared. You're actually using this language, correlation, association, and relationship. You're describing the coefficient of determination using the right language. You're interpreting R squared using the right terminology. So you're talking about the variation in the variable on the y-axis, which explains the variation in the variable on the x-axis, using the actual context as well. You understand the difference between a scatter plot and a residual plot. I often see students refer to the residual plot as a scatter plot. It is not. It is a residual plot, and you know what its purpose is. You understand that purpose of the residual plot and you interpret it correctly. So you're not talking about a residual plot as having correlation, but you're talking about it confirming the linearity of your model. If you're doing time series, you understand the difference between a scatter plot and a time series. And if you are doing a time series, you're describing it using appropriate language like seasonality, trends, and cyclical changes versus a scatter plot where you're talking about form, direction, and strength. I often do see students get that mixed up. So you know the difference. That's mathematical language. You know the difference between correlation and causation, and you discuss those appropriately. Okay, and lastly, you know the difference between interpolation and extrapolation, and you're differentiating between those appropriately with your language. Here's a different type of assignment, measurement. You understand the difference between volume and surface area. They are both of three-dimensional objects, but they are use different units of measurement. One has units cubed, the other one has units squared. So you're doing that appropriately as well. That's those correct units of measurement. You're following accepted conventions. So for example, if you're using trigonometry to transpose equations, you're using the inverse of sine, and that looks like this, sine to the power of -1. So you're doing that properly, not as a big -1 to find an angle. You're labeling all those diagrams that you draw or create using technology appropriately. Here's some examples with geometry. If you're performing a proof, you're communicating that work appropriately. For example, for congruent and similar triangle proofs, there should be one line of proof per pair of angles or sides, and then a statement using appropriate symbols and naming conventions. So for example here, triangle ABC is similar to triangle DEF, and your proof reason is SSS, side, side, side. So making sure you use the correct symbols when you're doing your work. You're using all of those and labeling everything that you draw. If you're doing an assignment on probability, you're using correct probability vocabulary, and there's a lot of it, things like independent, dependent, event, sample space, conditional, all of those things. You're using the right words in the right context. Using proper probability symbols and terminology. So probability of heads intersecting with tails. So you've got these symbols here that you're using, and you're also setting up probability using brackets. You're using fractions, decimals, and percentages correctly communicated with the right symbols there as well. If you're doing a statistics assignment, you're using the correct vocabulary around mean, median, mode, range, and standard deviation. using the right formula for your year level. So if you're in year 11 and 12, you're not writing a formula that's all words, you're using symbols instead from your formula sheet. So for example, the mean equals the sum of scores divided by the number of scores is appropriate for 7 to 10, but once you hit year 11 and 12, you need to use this formula instead. Also, that you're interpreting the measures of centres and spread in the right context. Okay, for all topic areas, if you're doing a graph, your graph should have titles and axis titles with appropriate scaling. All your lines are labelled with equations when you're drawing a graph. So for example here, we've got the equation of this least squared regression line, we've got a title, we've got axis titles as well. They're also appropriate scaling there. Okay, all maths areas, when you're doing equations, use of formulas and recurrence relations. You're using language like substitute into an equation, not sub in or plug in. Okay, that's slang, it's not mathematical language. When you solve an equation, you solve it. But remember, expressions are not solved. Okay, so expressions are simplified instead. When we're using our mathematical language, we should be showing all our steps of working. So if we're working with a formula, we state the formula, state our variables, substitute into the formula, transpose the formula as required, we solve it, and then we state a solution in words using the context and units of measurement. So these are all parts of mathematical language. So here's an example from student B. They've stated the formula, they've substituted into the formula, they've come up with a solution, and they've used some words to state what the equation is at the end. Now earlier on they also stated their variables, but it was too far up to snip in one shot. But they've done all of these steps here. That's appropriate mathematical language. When we are rounding, we need to make sure that we are rounding appropriately. That's a convention. Okay, so when we round mid-question, that reduces the accuracy of our response, so we need to avoid doing that in that way. So it's a convention that if we are going to write on our piece of paper a number that we're going to use again later, we can typically represent that using ... or ... That tells the teacher that we haven't rounded on our calculator, we're just rounding it for the purpose of writing it in our assignment, but we're going to continue with the unrounded number for our calculations. Also at the end with our final solution, most numbers for things like measurement, we use 2 decimal places to round. That's a convention. However, bivariate data can be typically rounded to 4 decimal places or time series as well. When we're doing things like deseasonalization, we might round our numbers mid-question to 4 decimal places. Money is always rounded to 2 decimal places for small numbers, so $3.13. We round, instead of 3.1398457, we round to $3.13, and we use a currency symbol that's appropriate to the country's currency that we're talking about. So if you're doing an assignment involving exchange rates, you want to use the symbols for the currency that you're converting into. Now, if we've got large numbers for a money assignment, for example, we're buying a SOL unit worth $15,000, then we would round that to the nearest whole number, and we wouldn't do 15,000.00. We would just round to the nearest whole number. We also need to use linking language. This is part of mathematical language for all maths topics. So we do a brief explanation or a few words to describe the formula or to describe the graph that we're about to create. So for example, here in the QCAA's exemplar, they've explained very briefly why they're doing a residual plot. So they're linking that to the concept that they're about to talk about. When we change to a different calculation, so let's say we did one calculation for one formula and then we moved on to another calculation, we should have a new heading or a new explanation to explain that we're moving on to something else. Otherwise, it doesn't look like we're talking, it looks like we're talking about one whole thing. If we're using algebra, like solving equations or simultaneous equations, we should consider words to explain what we're doing. Now here I've got a student who is solving an equation and they've put in brackets what they're doing, and they're about to use this information in another equation. They're solving simultaneous equations here, so they've put some words here. Substitute this into equation 1. So this linking language is really important, particularly for algebraic techniques. Okay. I've already mentioned that we should also label equations if we're solving simultaneous equations. So if we've got a linear equation and maybe another linear equation or a non-linear equation, we should call one equation 1 and one equation 2, and then talk about that as we're substituting in. We should also only have one sign of equality, one equal sign per line of working. So you see this student is solving this equation, but they've got an equal sign here and an equal sign there. And on this line of working, they've got 3 equal signs. you should only have one equal sign per line of working. Well, that's all we've got time for today. I hope this was helpful to you in understanding what is meant by mathematical language. Obviously, there's a lot more nuances for each particular area of mathematics that you're learning about. Some great ways to make sure you're using the right mathematical language is to have a look at your textbook, have a look at your teacher's OneNote, the PowerPoints that they may have created, because they are exemplifying for you the right mathematical language, and you should be using that in your assignment. If you've got any questions about anything you saw or heard today, mcclutchymaths@yahoo.com is the place to email us. Well, I'm Natalie McClutchy. Have a wonderful day.